Software mention, it's a software development agency based off of Krakow. We're around 40 people working on a variety of technologies, but focusing mostly on React and React Native. So we're committed to open source. We contribute to React Native, Expo. We have a couple of our own projects. So if your app is using React Native, then you're likely running the code we've built. But before that, I used to work at Facebook. I got very lucky and been a part of the React Native team since the early days of the project. So today I wanted to share part of my story, the story on how navigation inspired some of the most interesting projects I worked on. And the story is going to be about evolution of navigation. So the story starts with navigation, but I'm also sure that many people here started their journey with React Native also with navigation. Because when creating a new React Native project, the first thing, one of the first decisions we need to make is to select a navigation solution that we want to go with. And if we do like a quick Google search, we will find that there are plenty of solutions. Like we can find a couple of options like React Navigation, React Native Navigation, maybe React Native router flags. So undoubtedly, this decision is not easy to make, especially if we just started learning the framework. And we just know very little about navigation, right? So so on top of that, it's also hard to change the decision at some point later, because it might require you to rewrite a lot of the parts of your app. But on the other hand, having those many choices, it's kind of good. It's good to have competition in this area, right? So the best thing we can do is to learn about like the strengths and weaknesses of each of those solutions. All right, so we've been staring at this graph for a while. And I forgot to mention that it's actually, I made it up. So it's, yeah, so it doesn't mean to be very accurate, but it actually illustrates a couple of interesting things. So first is that we've seen many different navigation solutions over the past couple of years. And it actually tells us a little bit about like how complicated of a problem navigation is. And the second thing is that we're perhaps not done yet. So I don't know what the next major thing for navigation is going to be. It could be that React Native Fabric brings something new to the table, or maybe one of the current libraries will have another major release. But whatever that is, I'm sure it's going to be mind-blowing. So let's go back to the old days, back in time, months before React Native has been even released as an open source project. Back then, React Native was iOS only implemented on iOS, and we started like being able to render native views with React. So then we wanted to build bigger apps, and for that we needed a navigation solution. So the natural thing to use was the UI navigation controller on iOS, and that's essentially what Navigator iOS is. So it wraps the UI navigation controller on iOS. Apparently, it's still a part of the React Native core. It's in the most recent version. You can find it on the documentation on the list of available components. And it has this short list of parameters. You can like customize the color of a navigation bar. You can customize the color of the text on that bar, or maybe the buttons that displays there. But this list of props is also the biggest weakness of Navigator iOS. So it's not really very customizable. On top of that, in the meantime, we also started working on Android support for iOS. And this guy wasn't really happy about this component. Because it was iOS only, it has a list that was of properties that was specific to iOS. We also realized that navigation works differently on iOS and on Android. Because on iOS, you have this top navigation bar that transitions when you push new screens, so they like sort of slide behind the navigation bar. On Android, you have a back button that is not available on, the hardware back button that is not available on iOS. Also, the navigation bar look differently. They have different heights, also depending on your phone. the text, the title is like centered on iOS, whereas it's aligned to the left on Android. So there are many differences. So the choice that we have to make is whether we actually want to like sort of implement a complementary native component that would do similar things as Navigator iOS for Android. But like knowing that this short list of parameters we have for Navigator iOS wasn't really sufficient for the use cases we wanted to have, we decided to go with a different solution, and that's how the Navigator came to be. So Navigator, it was actually called Navigator, so I just put it in quotes. It was a first cross-platform implementation. It has a concept of the route configuration, which is essentially like a map between route names and the components that renders within whenever we push a certain screens. And then we would use the imperative API methods like push, pop, reset to control what's happening with the Navigator. And most importantly is that they didn't require any specific native components. So given that we have the view layer implemented for Android, we could actually start using Navigator. But Navigator also has its issues. So one of the biggest issues was with the transitions performance. So the problem with transition animation was that Navigator was actually using request animation frame API. And the problem with request animation API specifically in the context of navigation is that whenever we are pushing new screen, then JavaScript thread is like rendering the whole new part of the app. There could be like many views on that screen. And once these are rendered, we usually like do network requests or we like read something from the local storage. So there's lots of things happening when we're pushing new screens. And on top of that, the JavaScript thread needed to run the animation. And that was actually suffering. So what would happen is that the animation would stutter whenever we open the screen sometimes. It wasn't like all the time, but like in many cases, it was actually happening. So what the solution would be to that? So we didn't want it to actually run those animations in JavaScript. We wanted to make them run in native. And thankfully, at that time, we had the animated API that was designed by Krzysztof Magiera. And for those unfamiliar with animated, I'll just do the quick overview of the API. So the basic building blocks are animated values that we can create and then store in component state or in like component class member. And then in render method, we can connect those values to attributes of the view. So whenever the value changes, the attribute will change as well. Then we can run animations for those values. So we can say that we want to animate fade from 0 to 1 in 300 milliseconds. So there are many options. We can do timing animation, sprint-based animations, and so on. We can also hook the animated values to events. Like, for example, with a scroll event, we want to map the Y offset of the scroll view to the animated value that would help us do things like collapsible navbar and stuff like that. So here we extract the Y offset from the event, and then we set it to the value. But there's also a declarative way of doing that using animated.event, where we provide a map of how the event properties would map to animated values. And finally, we can mix and match animated values. We can add them, multiply them, interpolate. There are plenty of different options. So we refer to animated as being declarative, and it's because we no longer use request animation frame here, in which we would like tell exactly how the view should update in this particular frame. But instead, we have this mapping of the value to view property, and then we can tell how this value should update over time. So this nice feature of the animated API allowed us to actually take this declarative description of how this interaction or this animation should look like, how the views should be updated in the meantime. And instead of running it in JavaScript, we could run it in native. And that's how the animated native driver came to be. So if you haven't heard about native driver, I recommend you check it out. But yeah, Navigator was still using request animation frame. We needed a new Navigator, right? That's how the NavigatorExperimental created. So NavigatorExperimental didn't have that problem with the smooth animations because it was using native driver. It also introduced this nice concept of that would allow us to access the navigation state. So instead of like just having imperative commands like push and pop, we could actually access the whole state of Navigator, and we could like modify, like remove screens from the middle and stuff like that. Sometimes it's useful. But it had a problem, and the problem was name. So when something is called experimental, then you're not very likely to use it. So at some point, we have 3 navigators in React Native core, and it was like part of documentation, this text. I'll give you like 30 seconds to read it. But anyways, yeah, I mean, it was difficult really to choose experimental in such a case. Around the same time, engineers at Wix released their new navigation framework that was called React Native Navigation. And it was kind of similar from the API perspective. So we have this route concept. We would register screens with names, and then we have the push, pop, reset methods to control that. That was different on the implementation side. So when using Navigator or NavigatorExperimental or Navigator iOS, always our whole app container is like the whole screen. So we have the navigation bar is a part of the app container. Whereas with React Native navigation, our app container is trapped inside of what we call the view controller. So whenever we push new screen, it's going to create a new controller and then create a new app container and then render the view inside of that container. So because the navigation bar is outside of the app, we need to use native APIs to like sort of set the look of it, right? So it's also like sort of tricky to render something on that bar, but like you can sort of create a new app containers and then render like small things on the navigation bar. So earlier I talked about Navigator iOS, that it has a short list of parameters. So to solve this problem, engineers at Wix had to go all in, and they made this. So this is like a specification of the style format for the Navigator. So there are like a lot of properties, and like really a lot. Yeah. Yeah, but so the bad news is that it's still not enough. So there are things that you cannot really do with this. Like for example, control the height of the bar, or like place a search bar in it. And there are also other limitations. Like for example, if you want to have this kind of effect where you have like a slide down to dismiss animation, it's kind of difficult to do because like the native iOS Navigator doesn't support this. Yet this is still like a very common pattern across different apps. But it's just not a part of the native UI navigation controller. So it's not supported in React Native navigation. And it's really difficult to implement that in React Native because like the navigation bar is not a part of your app. So you cannot really like get the touch events for when you start it on the bar, right? And even if you had, then you only have those methods like pop. You cannot do like pop halfway because I don't know if I'm gonna be dismissing or not. So you cannot really do it just yet. But as you can see, gestures are inseparable part of navigation experience, right? And we also kind of struggle with gestures in navigation experimental. So the problem with gesture was like very similar to what we experienced with running animations and making them run smoothly. And the source of the issue is the way the touch system's been designed in React Native. So it actually relies on communication between UI and JavaScript thread. So when we interact with a touch screen, there are like raw touch events being generated and delivered to UI thread. And then those raw events are just sent over to the JavaScript. And then in JavaScript, we like sort of try to figure out which components should be responsible for handling this touch stream. And then if we're recognizing pan, then we sort of translate those raw touch events into the pan events that is like dragging, like how far we have dragged since the gesture started, for example. Then we can handle those events in JavaScript, update view accordingly, and send the updates to native. So we have this long update loops that like starts in UI thread, then goes to JavaScript, and then get back to UI thread, which is very similar to how request animation frame-based animations work. So we can solve it in a similar way, that is, like try to move the responsibilities that are on the JavaScript side and like try to run this logic in UI thread, but leave like a declarative API that will allow us to control this logic that runs on UI. And that's essentially what React Native Gesture Handler was about. With React Native Gesture Handler, we have a bunch of different components. For each gesture type, we have a different component, so one for panning, for pinching, tapping, rotation. And then we can control behavior of those recognizers by setting parameters. Like, for example, for pan, we can like, specify how far we need to drag since the beginning for the gesture to recognize. And then instead of, as an output, we get events. So instead of actually getting those raw events, we get things that are related to the type of the handler. Like, for example, for the pan, we'll get the translation. For pinch, we'll get the scale. And for the rotation, we'll get an angle. So this is how you render that in React. So you render the gesture handler component, and it's actually being activated on the view that is directly inside it. So the view that is inside it, whenever we like start rotating on that view, it's going to activate the gesture. And since the events that gesture handler generates are not like just raw coordinates of the fingers, because for rotation we actually get the angle, we can map that to animated value and use native driver to like drive it without interacting with the JS thread at all. So yeah, I mean, gesture handler has been around for a while, but we haven't really been taking advantage of it in the context of navigation. But if you've watched Eric's morning talk, you know that's about to change. So yeah, Eric talked about React Navigation, which is like a final evolution of a JavaScript-based navigators. It's been around for like 2 years almost, and it's been designed with the main goal of being customizable. And by customizable, I don't mean like adding another 200 parameters to be able to like control everything, but it's more about like exposing. It's more about like giving you a way to like override the default behavior if you want to. Like, for example, good extension point was what Eric was talking about. That was the transitioner API. We have similar things for like intercepting push and pop things with React Navigation, and there are a couple of other extension points. So yeah, with React Navigation, we can do screen transitions that runs on the UI thread. We will be using native gestures for the back swipe. We also can use like native gesture handler-based story components. So the question is if it's still like valid to discuss if React Navigation is a native or it's JavaScript, whatever. Yeah, I mean, if you look at those two apps, these are actually like two different apps, but they don't seem like that. One is using React Native Navigation, one is using React Navigation, and I don't remember which one is which, because they're really very, very similar. So like, as far as visuals goes, it's like really hard to distinguish between these. So to answer the question I was asking on the previous slide, we actually need to go deeper. And by go deeper, I mean like look at the things that are not visible to the human eye. One of those things is this button over here. It's hardly visible, and it's an Xcode. It takes a snapshot of the view hierarchy. So when you click it, it's gonna like take a snapshot and visualize it, so you can see the whole hierarchy of views as a tree, and then also like drawn in the middle. You will see it in a moment. And then you can also rotate it to see it in 3D to see like how all the layers are set. So let's try it. Oof. Yeah, so we can rotate it now and then see how the layers are looking here. Yeah. So this is like the third screen because we index from 0. And we have 2 screens on the stack that are just not here. They're gone. They're like unmounted by the navigation controller. Let's do the same with React Native navigation. So we click it, we get a snapshot, and when we rotate it, we're actually gonna see the previous screens. So yeah, I mean, they're there because we're just rendering views. We're not rendering UI navigation controller. And so those views needs to be somewhere. I mean, don't get me wrong, with React Native navigation, they're still there. They're just not mounted in the view hierarchy. So the views exist. They're in memory. We keep their state, but they're just not mounted. So the question is it okay to actually have those views there? So one problem is, so it's kind of okay and kind of not okay. So we sort of, so since they're there, the rendering pipeline would actually need to take those into account. So when we're rendering views, we're like converting like the views that we made to like GPU commands, so like draw a rectangle or draw something else. And the list of commands is called the render list, and this list is just longer in this case. And it has to go like through the list in order to like render this whole screen every time, like in every single frame. But the good part is that the rendering engines are usually optimized for something that is called overdraw. So they actually draw from the top layer, so like with the highest Z index. And once they fill the whole space, they just stop. But still, like those views are in the render list. They take up some additional memory resources. But the bad news is that this is not all. So when the view are kept there, they don't actually go through the concept that we call a view lifecycle. And this is a bit different concept than the component lifecycle in React, because views can exist, but they can be unmounted, right? They're somewhere hidden outside of the site. And most of the views just like ignore lifecycle because they don't really can do anything about it, but some views can optimize for being unmounted. Like for example, when we have like a map view that displays user location. So we set an attribute track user location, and then what the view does is it like starts request location notification changes, right? So we're like starting tracking location just because we set some attribute on the view. And then when the view goes outside, and we don't, and if we forget to trigger that lifecycle, then it will like keep tracking user location. So that's one example. Another example is with cameras. So let's say that we have like a camera preview view that is actually like retaining a session to camera. It's like pulling the video stream, even so it's like unmounted or somewhere like down the navigation stack. So this is kind of bad. Like if we were to do it in native, we would have like those methods over here. So we have a callback will move or did move to window on iOS, and we have unattached to window or undetached to window on Android. And since with React Navigation, those are not triggered, then the views doesn't have the opportunity to release some of the resources they store. There is the list of resources, so it could be memory. Like for example, we have an image view, and the image view displays a JPEG, so it stores a JPEG in memory, but it also needs to render it, so it needs to decode it. So it actually stores like 2 copies, so it stores like the encoded image and decoded image. Those are all kept in memory, but when it's unmounted, we could potentially release the memory where we store the decoded image. There are also some system resources like the camera sessions or like the location notifications. And there is also CPU resources because like some views like for example, especially maps, just have their own render loops because they render directly to OpenGL. So we need to make sure that those loops are stopped. So when Vue is detached, they should stop running. Otherwise, we're just wasting CPU resources. So screens does not behave like regular views, so we shouldn't really be using views for rendering screens, but we do. So how can we solve that? Do we really need to have this? Well, the answer is, like, if we really take a look on those parameters here, you'll notice that these are actually all about like the nav bar or the tab bar here. So these are like visual elements, and we looked at the visuals before and we couldn't tell the difference. So maybe it's okay like to get rid of the elements of the parameters that are just visual. So if we remove the visual ones, then we're left with nothing. So we just have the screen container, and inside that screen container we can render a screen, and we have this attribute for the screen that this screen should be active. So like for example, we can do things like a tab navigator where we have like 3 screens inside of the container, and then only one tab is active. When we switch between the tabs, we can activate other elements of this array. We can also do the stack navigator, in which case we will always have the last element of, the last child is going to be active, right? Unless we're doing the transition, because when we are transitioning, we need to see both. So we need to have 2, so we can just like that. So we have 2 screens active, and then once we're over, then we just remove the other one. Cool. So I just described to you, like, this is the whole, I mean, this is everything, the whole API of the new project I call React Native Screens. That we have actually like started a few months ago, and it's sort of ready by now. You can use it. You can use it with React Navigation. The integration was like very easy because we just like swapped out some of the views to screen containers and to screens. So if you go to GitHub for native screens, you will see the instructions how to get it to work with your React Navigation. You don't really have to make any changes to React Navigation, like at all, to your app, sorry. It's just like an internal change of React Navigation. The only thing is that you're going to need to install native components that React Native Screens ships with. And yeah, finally, it's also going to be in Expo and release the version 30. So it's going to be out very soon. So hope you will all be able to try it. And yeah, so this is the last slide. We just have on the left, there is an app that doesn't use screens, and like it's like a really shitty Android phone. So when we like push many screen with images, then it like starts, it just slows down a bit. Yeah, really bit. I mean more than bit. And on the right-hand side, we have screens. So, whoops, yeah, there you go. So the transitions are way faster because the image view component can actually release the resources that they're taking. Yeah, that's it. Thank you.